Hi. Okay. I'd like to say three's a charm, but this is take number 4. Let's try to get it started here. Okay, this is quant. This is quantitative reasoning and skills class. I'm Dr. Heather Kelly, and we're going to get started here. Okay, we're going to start with the first section. And traditionally, this first section makes people want to turn around and run. Do not do it. Okay? It is my grand pleasure to let you know that in general, the first section is the hardest section in the entire course, okay? So just grin and bear it, make it through, ask me questions, come see me in my office hours, get some help, go to the ACE. Danielle at the ACE is awesome. She did really good in my class. She's been tutoring this class for a couple of semesters. So let's get started. First off, let's just start talking about percentages. And I know that you know what a percentage is. Of course, you've made it all the way to college, but let's talk about some details that you've probably not thought about as far as percentages go in quite a long time. So let's just start off with 35%. Okay? So when I write it like this is in the percentage. I'm not going to be able to write. I'm not, you guys heard me at the beginning how many times I've redone this stupid video. If I make a mistake, we're just sticking with my crazy mistakes today. Okay, so this is percent. That's in the percent form. And one thing that I have to note here is you can never, and there's not a lot of nevers in math, but I'm going to write it in bold, big, and underline. You can never perform any operations, and that means add, subtract, multiply, or divide, while in this form, okay? We use the percentage form to kind of describe something greater than just one item. When we say we have 35% of the cookies, that tells you something more than just 35 cookies, right? Because maybe it's not 35 cookies. So a percentage talks a little bit broader than just the number. All right. Now, how do we actually deal with it? Well, by definition, 35% is 35 per, over a line, 100. And this form right here looks like a fraction, and it is, but we're going to call this the ratio form. Okay, because ratios are fractions that we've kind of formed ourselves out of word problems, basically. Okay, so this is ratio form, but I'm going to also write fraction down here. Now, the one thing that is super duper important about ratio form is for it to be in that form, the denominator, that's the bottom, right? The denominator must be a 100. Must, oops, I forgot the must word. I'll stick it in here. Must be 100 for it to be related to the percent. There's ways to make that happen, right? There are ways to make that happen. And then finally, of course, you know, every fraction can be rewritten as a decimal. And so this could also be written as 0.35, and that is in the decimal form. Okay? And decimal form is the desired form. Decimal form is the form that we use, this form, most often over, most often, not all the time, but most often over the ratio form to solve problems. All right, so When you see a percentage in a problem given to you, you have to convert the percentage to decimal, and we're going to talk about that here in just a second. Now, another thing that I like to do in my class is give you students something called a you-do problem, and that's like a problem for you to just kind of, test the skills out or whatever. I'm not quite to the you-do yet, but I don't want you to be surprised when I do hit you up with one. Okay, so let's take a look at this next example here. Now, what this is actually asking us to do is to set up a ratio and then turn it into a percentage. Okay, and ratios are, as you may remember, the part over the whole. Okay, now it's not the big number over the little number, because you can have percentages that are greater than 100. Okay, so that is not the idea. It's just literally the part counted over the whole kind of situation. So when we look at a word problem here, we've got 324 people out of 400 state that they like dogs. What percentage is this? Okay, so the 324 is our part and our 400 is our whole, right? So first things first, the first thing we want to do is we want to set up the ratio. Okay, and here the ratio is going to be 324 over 400. Now the next thing we want to do is we want to make the denominator equal to 100, right? Because when it is the bottom is 100, then the numerator, the top number, just becomes the answer with the little percent symbol on there. So that's what we're going to try to do here. So let's take a look here. We have 324 over 400. So the idea is to get the denominator. We want to make this a 100 by dividing by 4, right? Now, what you do to a denominator, you have to do to a numerator, or you've changed the number altogether and it's not the same anymore. So we're going to divide the denominator by 4, and we're also going to divide the numerator by 4. And so let's see what that gives us here. 324 divided by 4 is 81, and 400 divided by 4 is 100. Once that denominator is 100, then we can easily write our answer. Now, I mentioned, I believe, and I'm not sure because I've tried to record this video 4 times this afternoon. So I think I mentioned at the beginning that I need you to give me all of your answers in word problem. If I give you the problem in the form of a word problem like this, I need you to tell me the solution in the form of a word problem. So here our answer would be that 81% of the people liked dogs. Okay, and that right there is what I'm looking for. You could write a better sentence. You could follow what they'll tell you in English, which is never start a sentence with a number, which was bad. I should have wrote out 81%, but we're not in English class, so I'll take it like that, right? But be sure to give it to me in a sentence or I'm going to take some points away. All right, following the directions are very important. So this next example asks us to write as a percentage. Now, you might readily know some fractions. You might readily know that 1/4 is 25%, right? And 1/2 is 50%, and so forth. And you might even know some others, like 1/5 or anything like 1/5 of being 20%. There's some that you might know, but you might not know that. What do you do if you don't know that? You can always do long division and convert the decimal to a percentage. Okay, we can always do that. And so let's do that. So if we set this up and do long division, that is 2 being divided by a 3. And when you do that, you get 0.6666666. It goes on forever. In fact, we write that as 0.6 with a line over it. That line lets us know that that 6 repeats. Now, when we have a decimal and we want to turn it into a percentage, the way we do that is we multiply by 100. So multiply by 100. To get the percentage form. Okay? So when we multiply this by 100, we're going to get 66.6 with a repeated line, and we throw in that divided sign. Okay? So that's the deal. We're going to multiply it by 100. So our next question here, let's have you do this. So you do this one. Now, when it comes to you-dos, and this one's kind of quick and easy, I think even by the time I quit talking, you'll have the answer. But typically when it comes to a you-do, I'm going to sit here quietly while you work the problem. If you don't quite get it done in, say, the minute or so of time that I allot to you, then I want you to pause the video and finish working the problem and then restart the video to see how you did, okay? Because you-dos are really important to just kind of judge and see, are you following, are you keeping up with it, and stuff like that. All right, now I assume you've already multiplied this guy by 100, which is what we do. And let's point out the fact that when you multiply by 100, you move the decimal point to the right. So multiplying by 100, you just move the decimal 2 spots right. And I'm going to mention this now, but it's going to come up. So that means if you divide by 100, you're going to move the decimal point to the left, right? Okay, so 0.015 is equal to 1.5%. Now don't forget to put the percent sign, because remember, the fact that percent sign says a whole lot more than what that number itself says, because that percent represents kind of like a whole group of numbers, a type of number. All right, and then let's take a look at this guy. We're going to go easy peasy here, multiplying it by 100 again because we're turning it into a percentage. And when we do that, we get it equal to 674%. And yes, it is absolutely okay to have a percentage that is greater than 100. Now, sometimes, depending on the context of maybe what someone is saying to you, it may not be that something can possibly be more than 100. But when you start talking about growth or things changing, or money increase or depreciation of, say, a value of a car or something, those can be percentages that are above 100%, because you can have growth that is more than 100%. We'll see if it comes up for us to talk more about that. All right, so again, I want to remind you that all solution in this class must be given in a complete sentence. If I give you the question in a sentence, You give me the answer in a sentence, okay? So let's take a look at this example. This example says that the sales tax in town is 9.4%. How much tax will you pay on an item costing $382? Now, I know you all know how to do this because you make purchases, you go out, you buy things, you understand the way taxes work, but you're not computing it while you're sitting there trying to figure out what 9.4% of tax is. You're depending on computers to tell you. So let me just remind you kind of technically what the math is here. And so when we want to know a total cost including tax, that's going to be equal to the cost plus the tax on the item, right? And how we get the tax on the item, that is getting by multiplying the cost by the percent taxed. Now remember, we can't work any of these problems when we're still dealing with percentages, but just for the way that I'm writing it here, so we can think about it. So we're going to take cost plus the percentage of the cost and add those two together, and that's going to give us our total here. So a reminder that you're given a percentage, and anytime you see a percentage in a problem, you know you're going to have to compute something. We want to convert to a decimal. So that's going in the other direction. We're not turning it into a percentage, we're converting it to a decimal, and we do that by dividing by 100, which is moving the decimal place 2 spots in the negative direction, which would be to the left. Okay, so that's what we're going to do. So the first thing first, we're going to take our 9.4% and we're going to turn that into a decimal, which means we're going to move this 2 spots, so that becomes 0.094. I always make a practice of putting a 0 in front of my decimal point, because sometimes your decimal points aren't great, they're kind of astray and you can't really see it, but if you go ahead and set that habit, it will really be successful for you as we move forward in this class. Okay, so that is my sales tax, and so my total here is going to be, my total is going to equal our 382, so that is our cost of our item, plus our percent, 0.094, times the cost of our item. All right, and when we do the math there, we have 382 plus, did I show the math? I didn't, but I will pull out my calculator here real quick. 382 times 0.094, that is 35.908. And when we add all that stuff together here, my brain is so taxed. You will learn that I am terrible at arithmetic, so I like to always check my stuff. So this would be 417.908. Now, of course, we're dealing with money, and we only go to the penny in money, right? We only go out 2 decimal places. So you would need to finish this by rounding this to 91 cents. And then the final thing is you need to answer it in a sentence. So you would pay $35.91 of tax. Now notice that was what the question was. I thought the question was how much will the final cost be, but actually the question is what's the tax amount? I just looked over there and read that, and it literally says how much tax will you pay on an item. So we didn't need to do all that. We didn't need this part. We really only needed this part. But that's okay. That's just the way that we're going after it. Okay, sorry, my phone was buzzing. All right, I apologize. I usually try not to look at it while I'm recording. Here we go. Sorry about that pause. Let's keep on going. Now, the next thing we're going to talk about is the absolute and relative change. And this is the way you find the percent of an increase or a decrease, kind of like the amount of money in my bank account, or how much my car is depreciated. Let's think about something that would increase. Oh, my level of stress. Just joking. Anyway, this is how it's done. So let's take a look here. The first thing, it's a three-step process. And the first process is to find what's called the absolute change. And the absolute change is the numerical difference between the start value and the ending value, okay? And I want to make note here that this is not some notation. This is the absolute value. And remember that that is a math function. The absolute value is a math function you've learned way back in elementary school, and you've been dealing with it all the way through. But let me just remind you that the absolute value of -2 is equal to +2, and the absolute value of 12 is equal to 12. Basically, what the function of the absolute value is it's like how many spaces are between 0 and the number inside the bars. We don't care what direction, if it's positive or negative. We just want to know how many spots are there. Okay, so that's why you drop the negative off when you do an absolute value. It's not that you change a sign. It's that the absolute value just says ignore the sign. We just need to know how many spots are there. Okay, so that's the first thing we do. We find the absolute change. Second thing, we identify the starting value, because that is always going to be the denominator. The starting value is always the denominator. And then we compute something called the relative change, and that is that change of difference relative to the starting value. That's where the relative comes in. It's like relative to the starting value. And then this is the function here that we will use. So let's take a look at this first example. So here it says the value of a car dropped from $7,400 to $6,800 over the last year. What percent decrease is this? So the first thing I'm going to do is I'm going to identify my starting and ending value. Well, when you bought the car, which is the start, it was $7,400, and the end is the $6,800. Okay, so the first thing we want to do is find that absolute change. And all that absolute change is the absolute value of the difference between $7,400 and $6,800. And when you do that math, you get 600. Oh, look at that. I did it backwards. I told you I'm not going to redo anything, but I'm going to correct it, okay? I'm sorry. I didn't follow the directions. It's end minus start. So let me just get my 6,800 minus 7,400. That is equal to the absolute value of -600, which is equal to 600. It really doesn't matter. There's only 600 numbers between 6,800 and 7,400, no matter which direction you go with. But I'm trying to be technical, so when you look back and you try to follow this later with another problem, you're like, why did she write it like that? I thought it was this way. Okay. Again, this is just one little teeny weeny bitty tiny part of chapter 1 of unit 1. In fact, we're going to step away from this pretty darn fast and just work with financial formulas that we just plug numbers into. So just keep on keeping on with me. Now, the second thing said identify the starting value. Well, the start value was 7,400. Okay, so our relative change is equal to 600 divided by the 7,400. And when you do that math, we get 0.081 continued. Now be careful. Notice this. That repeat line doesn't cover that 0 right there. The repeat line is just covering that 8181. So really what that number is, and I'm just going to write it here because I want to make sure that you understand this little nuance, is it's like that, right? Okay. So right now this is as a percent, as a decimal, but we need to get a percent for the answer. So remember, what do? We multiply it by 100, which is the same as moving the decimal point 2 spaces. So that is equal to 8.181. Okay, that's how you'd have to write it so that it would be technically correct. Now, am I going to take it without the line on it and you being careful? Absolutely. But I want to make sure that you understand how it really works. Okay, and then we'll write our answer here. The percent, the car value decreased was 8.2%, because what I did is I just rounded that up. Okay? And that is very satisfactory. Now the good part about this class is all of the homework, all of the quizzes, all of the exams are pencil and paper, meaning they're free response. You don't have to do them through a computer program. You don't have to, fit something that the computer's going to grade. I'm going to grade it. It's going to be a human that looks at it and goes, oh, okay, that's what they did. They rounded it or they didn't round it. You know what I mean? So just okay, so let's take a look at this guy. All right, so we need to deal with here the relative change. But in this case, we're going to be dealing with either the QFC minus Albertsons over Albertsons, because remember it is end minus start over start, or we'll be dealing with the Albertsons minus QFC over the QFC. Okay, so the first problem here asks us to compare the number of QFCs against the Albertsons. This makes the QFC the start. We could also use the word base of comparison. Okay, and so that means that for this one, QFC is the bottom number. We're going to use this guy right here. So let us set this up. So we would have the absolute value of 215 minus 75 all over 75. And when you do the math there, you get 140 over 75, which is, I guess I'll just write that, which is 1.867. Now this is the decimal. You have to now convert to a percentage to finish. Okay, and that, remember, we just did that a minute ago, and that's moving the decimal places 2 places to the right and adding that percent sign. So this is 186.7%. And so what can we say here in the comparison against Albertsons is we could definitely say that Albertsons is 186.7% larger. So that's what I'm going to say is Albertsons is 186.7% larger than QFC. Right, and we can see that by looking here, 215, 75. We know that the Albertsons is larger. We've just managed to do the math, so we know how much larger. That's the only difference here. So if you're like, gosh, I don't know how to write this, go back and look at the problem. Think about it in like, which one's bigger, which one's smaller. What could you say about it? It's hard to be right or wrong here. So just, do your best. And now let's compare the number of Albertsons against the KFC. So, which is now making me hungry. 75 minus 215, in this case, over the 215. That's going to give us 140 over 215. Which when we do that math there, we have 0.651. And when we convert that to a percentage, that's moving that decimal place twice. We have 65.1%. Okay. Now, we're comparing, so we're going to start off with KFC is. So here we started off with Albertsons is, because that was what we were comparing against. So this one we're going to start off as KFC is, and then what is it? Well, it's smaller. By looking here, what can we say? Well, the only thing we can really say is it has less stores. So KFC is 65.1% smaller as far as number of stores in the U.S., smaller than Albertsons. Okay, awesome. All right, let's go to our next slide. Okay, so this next question says, suppose a stock drops in value by 60% one week and then increases in value the next week by 75%. Is the value higher or lower than where it started? So take a minute, think about it. What do you think? But let's do the math and check it out. Now, here's the thing. Not everything that you need is given here. You really need to run this scenario. You need to choose a value and actually do the math and see what happens. It's really hard to kind of decide how it's going to turn out in your head. So you just need to choose an arbitrary value. So we could use $1, $10, $123, $100, $1,000. It doesn't really matter what value we use, right? It could be any number. Now I'm going to choose something easy to work with. $100. That's the number I'm going to choose. And what we're going to do is, since the question is the value higher or lower at the end of these 2 weeks, then we're going to actually just run the work here. So let's look here. Week number 1. We start off with $100. And then the stock drops by the $100 times 60%. And remember, 60% is 0.6, or you could write 0.60 just to kind of make it see in your head that it's not changing the number, it's just changing the position of the decimal point. So I'm going to write it like this. Okay, and so that is 100 minus 60% of 100 is $60. So 100 minus 60 is equal to $40. And so at the end of week 1, this is how much? At end of week 1, okay? So let's look at week 2. What happens the second week? At week 2, we don't start off with $100 because all we have left now is $40. But we increase our $40 in value by 75%. So we have our $40 times 0.75. That's going to give us $40 plus $30, and so 70 is the end of week 2. Now the same trend would have happened no matter what number you chose. If you chose 200, if you chose 1,000, if you chose $25, it still all would have worked out to the same. Now, the smaller number you go when you do this, so why didn't I choose $10? Well, then I'm going to be dealing with cents. I'm going to be dealing with all the little cents, and I don't want to deal with no stinking cents. The question was, is the value higher or lower? So that's how we're going to solve it. So our solution here is the value of my stock is lower. All right. Oops. Kind of sloppy. That's okay. I like to square them up so when you ever look at this again, you can tell exactly where the answer was. Okay, let's look at another one here. Now, this is similar to the last idea. Okay, so it's pretty tempting to just average these guys together, right? And be like, oh, well, 40 and 30, that's 35%. But I know I've got basketball players on here and basketball fans on here, and you know that the number of attempts of a 2-point basket is not the same as the number of attempts at a 3-point basket. It's just the nature of the game, right? And so this is really a pretty crappy question, but we're going to go with it, all right? So it asks us to find the player's overall shot percentages. And to do that, what we have to do is determine how many attempts. So we're going to assign, the number of attempts for each type of shot. Okay, now we already discussed, and I'm sure you know, that it's not going to be the same. It's not going to be the same. Now, you might have a hot dog, you might have a superstar that happens to shoot more 3 points than 2 points, but I've taken some polls of a bunch of classes, and people pretty much tell me that a good a good guess here would be 200 2-point shots and say maybe 150 3-point shots. Now, you might disagree with me, and that's okay. This is just what I'm going to use. And you could do it another way. But the thing is however you figure this out, you have to be able to back it up, right? You have to say, I think that the player's overall shot percentage looks like whatever we're fixing to figure out based on there being 200 attempts at 2-point shots and 150 attempts at 3-point shots. Okay, I mean, that's really where it is. That's the qualifier. Okay, because if I come up with a number that's different than your number, and my number is based on the fact that there's 200 and 150 respectively shots made, but your number is 300 and 200, then of course the percentage is going to be different. So that's how you would handle one of these questions. You just be clear in the answer. So we're going to assign these values for each shot, and then we're going to figure it out. And so let's see, for the 2 points, that says that 40%, so we're going to multiply by 0.40, and the 3 points is 30%, so 0.30. So let's compute the 2 points first. So that's 200 attempts times the 40%. 40% of 200, and again, I didn't work this out. Oh, maybe I did, is 80. And then for the 3 points, we said 150 times 30%, and I think that's going to give us 50, but let me check, because, listen, that's 45, which I knew something was wrong. That's 45 shots, right? And so if we want to add them all up, so first we figured out each one. Now we're going to add them up. And then we need to find the relative. Well, it's kind of like finding the relative percentage here. We're going to do the sorry, my brain just stopped. Don't you hate it when your brain just stops? We're going to do the, let me put it over attempted. Do the made shots. My brain is not working here. The successful shots. It kind of kicked in finally. The successful shots are over the attempted, and that's going to give us our shot percentage, right? And so we were successful totally in 125 shots over the 2 different kinds, and the total number of shots we took were 350. So let's see what that percentage is. That gives us 0.357, which is going to be 35.7% shot percentages. And I know that's not a great sentence. That's the one, and it would work for me. I'd be like, okay, you know what that actually means. The only real reason why I need a full sentence is a lot of times students will compute answers but not know what the answers mean. In this class, it's quite important for you to know what the answers mean. All right, now let's talk about proportions and rates. I mentioned rate before and ratios, right? Thinking of fractions of 2 quantities, and if I didn't mention it before, I am sorry. Again, this is my 4th attempt at recording this in a row, so I honestly can't remember what I said on the other ones because I do not follow a script, clearly. Okay, but when you're writing a rate, you always have the units. And so here's an example. Like here I said 20 mph, right? And we know that that's 20 miles per hour. And if we wanted to write it as a rate, as a ratio, we would write 20 miles on top over 1 hour. Or like this example here, 8 feet per second, right? 8 feet on top over 1 second. Whatever the per is goes on the bottom. Okay, the first part of the unit is the numerator, and the second part of the unit is the denominator when you set these up. Now I'm talking about this because we're going to use proportions, and proportions are awesome. Proportions are really easy to solve, and proportions occur when you have a fraction equal to a fraction. Now it has to be a full-on fraction. It can't be like x over 2 plus 3 equals 1/2. That is not a fraction equal to a fraction. It literally has to be the only thing on the left-hand side of the equation is a single fraction. The only thing on the right-hand side of the equation is a single fraction. And I show you right here with this example, right? Fraction equals to a fraction. And in this case, the way that you solve this is cross multiplication. This is the only case that you get to cheat and use cross multiplication ever in solving math problems. It only works when it is a fraction equal to a fraction. All right, so this sets up the equation 3x is equal to 5 times 6. We have 3x is equal to 30, and I'm sure you guys remember how to solve a problem like this. That means x is equal to 10. Now, don't need to write a sentence here because it wasn't a word problem, right? So x equals 10 is satisfactory. Let's look at the next example. The next example says your car can drive 300 miles on a tank of 15 gallons. Express this as a rate. So this is kind of like saying 5 miles per hour, but this is 300 miles per 15 gallons of gas. So we can change in our thinking that on a tank of, and we can replace that with the word per. Now remember, anything that comes after per, that is in the denominator. And anything that comes before per is the numerator. You must include the units. So this is going to be 300 miles over 15 gallons. This is the rate. Now, this is a fraction, and fractions you can simplify. Even fractions that have units, all we're going to do is deal with the numbers here, right? 15 goes into 300 20 times, and we're left with 20 miles per 1 gallon. Now, that's what it asked us for. It asked us to find that rate, and that is the rate. So the rate is 20 miles per gallon. Okay. Then it says, how far can it drive in 40 gallons? Well, if this is 20 miles for 1 gallon, we just need to multiply it by 40. But let me show you this using some dimensional analysis. Not all the time is dimensional analysis the thing to do, but often it is when you're trying to change units or something like that. But let me show you the setup here. We're going to start off with our rate, which is 20 miles over 1 gallon. And then we're going to multiply it by the 40 gallons. Just over 1, because that's not gallons per anything. That's just gallons. So there isn't anything to go on the bottom that has units. Now, the thing to remember here when we talk about dimensional analysis, and I'm going to do a few more problems after this, but the thing that we really want to remember here is when you use dimensional analysis, the units are very helpful to set up the problem because units must cancel on the diagonals. So units must cancel on the diagonals, and because the gallon is down here and the gallon is right here, when we solve this problem and finish it up, this equals 20 times 40 is 800, and we're left with miles. Not miles per gallon, not anything, because the gallons went away. Now, if you didn't look at it in terms of dimensional analysis, you would have just said the 20 times 40, and you would have just straight up told me it was 800 miles. But I wanted to take something that you already kind of knew how to solve and put it to you in terms of the dimensional analysis we're going to be using on the next problem. So let's take a look here. Now, we use dimensional analysis usually when we need to convert units. And the main thing that we use when converting units is the main thing we have to have is conversion factors. Those are sometimes given to you, but sometimes they're common knowledge. So like a conversion factor that you know, 365 days over 1 year. Let's think of another one. 60 seconds in 1 hour. Or we could say 1 hour is 60 minutes. See that we can swap this stuff around, or like we could say 1 year is 12 months. Okay, so that's why it's important that we follow the units as far as when we set up our dimensional analysis problem. So let's take a look at this question. This question says a bicycle is traveling 15 miles per hour. So I'm going to set that up right away. That is 15 miles. 1 hour. Okay? And then it says, how many feet will it cover in 20 seconds? So we have a couple other things to do. So let's notice what we need to do. First, we need to convert miles to feet. And we also need to convert hours to seconds. And finally, we need to multiply by 20 to find the solution for 20 seconds. Okay? Now, I find it's really, really helpful if you kind of write down a plan when you're dealing with word problems like this. Write down a plan. Get the steps down before you start working on it, because you might start going and then you're like, oh, but what is the next? What is the other thing I need to do? So now I kind of have a plan here. I'm also going to write down my conversion factors that I'm going to need to use. And this is not something I expect for you to just walk around and know, but 1 mile is equal to 5,280 feet. Okay? And what I do expect you to know is there's 12 inches in a foot. I mean, common things like that. But this, I don't expect you to just pop that off on your head. But I do expect that you know that 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. So 1 hour is equal to 3,600 seconds. Now, you could use these two together, or you could use this one alone, right? Because that goes hours to seconds. Okay. Now I have everything I need, because I know I'm going to have to go miles to feet. I got that conversion factor. I know I have to go hours to seconds. I've got that conversion factor. And I know I'm going to need 20 seconds at the end. So we'll work on that when we get there. Okay, so it does not matter what order you do this in, but I think I'm going to convert my miles to feet first. And so miles is on top. So miles needs to be diagonal because those units will cancel on the diagonal. And so if a mile is down there, then I'm going to have feet up here on top. And then we're going to take our conversion factor here and we're going to stick these numbers in where they should go. So there should be a 1 down here on mile and the 5280 up here with the feet. So we got that piece done. Now let's do the next piece. The next piece is hours to seconds. All right, so you ignore this green guy. We don't think about this, but we look right here and we say we've got hour on the bottom. So we're going to have hour on top here. And we're comparing hours to, in this case, seconds. And when we come down here and we take a look here, we're going to put the 1 on the hour part, and we're going to put the 3,600 on the second part. Now, before you do any math, you want to cancel out the units and make sure that you're left with what we need. And what we need is feet per second. That's where we're going here. Okay? So let's just take a look and let's check it out. We have miles here. We have miles here. We have hours here. And remember with fractions, you can go across many of them. We've got hours here. We are left with feet, and we're left with seconds. Now the last step here is just like the last problem we did. The last thing it needs us to know is how many is it going to cover in 20 seconds. And that's not 20 seconds per anything. It's just 20 seconds. Okay? And we need to cancel the seconds because it says how many feet. So we got to get rid of the seconds. So now we get one more cancellation here. And when we do the math, and let me do the math real quick with my handy dandy calculator. Remember, when you're multiplying fractions together, it's shirts times shirts, pants times pants. You got to go all the way across, or we could put it in another way. But I'm going to say 15 times 5280 times 20 and get that numerator, and I'm not going to write it down or anything. I'm immediately going to divide by on my calculator. I'm going to hit here and say divide by, and I'm going to say 3,600. That gives me 440, and what are we left with? So our answer is 440, and what are we left with? Feet, of course, because that's the only unit that we're left with. And now we're going to write our answer. We would cover 440 feet in 20 seconds. Okay? Awesome. Couple more. Here we go. If your average heart rate is 80 beats per minute, how many times does your heart beat in a year? Now, this one I want you do. Okay, I'm going to give you about 2 minutes. You need to set up the original rate, determine what you need to convert to, what are we having to change, and then write down that conversion factor, and then work the problem, okay? So we need, I'm going to be quiet and write this down while you work on it, all right? Okay. Okay, let's get this going. If you have not finished and you want to finish and you're like, oh, I'm almost done, pause the video right now. I'll still be here when you unpause it. Okay? All right. So first, let's get our rate down. I want to write down our rate, and that is 80 beats in 1 minute. Okay? And we're going from minutes to years. We need to convert minutes to years. Now, we're not going to have that in one quick, easy step, but I guarantee you we can get there pretty quick on this. All right? Now, I'm going to pause the video for just 1 second, and then we're going to work on this. But part of this class requires you to take an attendance quiz, okay? After every lecture, there's an attendance quiz, and the attendance quiz is just a quick phrase that is ridiculous and does not make any sense to what I'm talking about that I'm going to say randomly during your lecture, okay? It won't always be at the beginning. It won't always be at a you do problem. It won't always be at the end. It will be random. I will not generally tell you that this is the phrase. I will for the first couple of lectures to make sure that you understand the process, okay? So I am pausing right now to tell you right now, this is your attendance quiz phrase, and it is ridiculous as they all will be. I am ready. Are you? Okay. You want to write this down. So remember, you get to pause the video and go backwards and write it down if you don't get it. Okay? So, a skunk borrowed my skateboard today. That is today's phrase. A skunk borrowed my skateboard today. I mean, the word is not today. Darn it. Let me start. A skunk borrowed my skateboard. That is the phrase. A skunk borrowed my skateboard. Okay, back to this problem. All right, so we got to go from minutes to years. Now, how are we going to go from minutes to years? Let's think about how we could go from minutes to years. And I'm actually going to do it within the problem because there's quite a few things that we're going to have to put in there to go from minute to year if you think about it. And so I just want to not talk about it and then do it. I want to just do it. All right, so first off, we got to get rid of the minutes, right? And what can we do to minutes? Well, the easiest thing is minute to hour because we know that really easily, right? So there are 60 minutes and 1 hour. The largest thing in your conversion factor, the largest thing in your conversion factor gets the 1. The largest thing in your conversion factor gets the 1. Okay? Now, that's not quite where we need to go. We're trying to get to years, so let's go hours. And how can we relate hours to a year? Well, we can go easily hours to days, right? So, what's bigger, an hour or a day? The day is bigger, so the day gets the 1. And how many hours are there in a day? 24. Okay, we're getting closer. Now, we only have one more, right? Because now we can go from day to year. And that's where we're trying to go, day to year. And year is bigger than day. So we have a 1 for the year, and we have 365 for the days. Now, before you do the math, just like on that previous problem, you want to make sure all your units cancel out, just in case you missed one, just in case you wrote something else crazy in there. You want to double check, right? Let's see. Minutes canceled to minute, hour canceled to hour, day canceled to day, and what we're left with is beats per year. Awesome. Now, when you do the math there, it is 42,048,000 beats per year. Okay? Awesome. Okay, let's take a look at this problem. This example says, what is the thickness of a single sheet of paper? What is its weight? Keep in mind that a ream, which is a package of paper, it's called a ream contains 500 pages and measures 2 inches in thickness. Okay? And it weighs approximately 5 pounds. So this is the information that we have. So we need to figure out what the thickness is. What are we working with here? Well, we know that 1 ream equals 2 inches. And we know that 1 ream equals 5 pounds. Right? And we need to know weight. We need to know pounds per page. So here we're looking for pound per page. That's what that rate we're looking for here. We're going to look for thickness, or inch per page, I guess. Let me write it that way. It's really helpful for you to figure all this stuff out at the beginning, okay, because it'll help. Now, if we want per page on the bottom, and our big conversion factor is a ream contains 500 pages. So we also know 1 ream equals 500 pages. And this is the one that relates the 2 pieces together. So we're going to start with that. And because we need inch per page or pounds per page, page needs to be on the bottom. And so the conversion rate we're going to use here is going to be 1 ream over 500 pages. That's how we've got to start both of these pieces. All right? So let's do thickness first. Okay? So for the thickness, we start off with 1 ream over 500 pages. And then we're going to use, if we're going thickness, we need this information right here, right? And we have to cancel something out here, and we're looking for inch per page. So the ream's got to go. So we're going to have to write the ream down here, and here we're going to do inches. Now see how it's all about where we set that unit. That's what lets us know how this math is going to go in here. So it's really, really important that you understand that. Okay, and then we're going to plug in our numbers here. So 1 ream is equal to 2 inches. And let's cancel out our units here. Our reams cancel out. We're left with inch per page. So that's what we need. And when we do that math here, we get 0.004 inches per page. I'm just going to write this, the paper is. Okay. And then we're going to do the same thing for the weight, but I'm going to have you do that. So let's you do the weight. Okay? It's going to go the same way. You're going to start it the same way. Give you about 30 seconds. Okay, so we'll start off again because we need pounds per page this time. We still need to start off with our 1 ream over 500 pages. And this time, we're just following it here. We're got to put page here. Oh, darn it. Sorry, I'm losing focus. We have to put ream here. And we're not dealing with pages. We've got pounds. So 1 ream was 5 pounds. And when we do that math there, we get 0.01 pound per page. So 1/100th of a pound. All right, cool. I think we're cruising on to our very last one. I can't wait. Here we go. Should you consider purchasing a hybrid car instead of a traditional gasoline vehicle? How do you know? You could listen to everybody, or you could just come up with a scenario, run the numbers, see what it looks like to you. Sometimes it's better to do something with your own hand, right? So keep in mind that the conventional engine, that's a gas engine, achieves 24 miles per gallon in the city and 35 miles per gallon on the highway, while the hybrid engine delivers 35 miles per gallon in the city and 40 miles per gallon on the highway. The typical driver covers 12,000 miles annually, with 25% of those driven on the highway. So the first thing you need to do is come up with a plan. How am I even going to solve this? What do I even need to do? This is a lot of words. Don't worry. We can figure it out. First things first, we need to know total highway miles, total city miles, right? And we got that right here. It says that we drive total of 12,000 with 25% of those being on the highway. So that's the first thing that we need to figure out. The next thing we need to do is we need to figure out how many gallons. So find the number of gallons of gas for each of the cars. Okay, now my brain just wandered here, and what it wandered was, this is really a crappy question, because we'd also, to really make a decision here, we'd also have to look at how our electric bill might be increasing. I still think that electric might turn out to save you a little bit on the gasoline, but I don't really know. Electric rates are pretty high here in Georgia, so I'm not really sure which way you would really want to go. But just for that, we're just going to figure it out, okay? We'll find the number of gallons of gas for each of the cars with all of the scenarios, and then finally we'll compare. Now, another thing that will help you very much when you're working these kind of problems is to be very organized. List out what you got going on. Just don't start off with the math. Write down what it is. Put a little title there, like nothing big, but watch here what I'm talking about. Like here I'm going to do a gasoline car, right? This is what I mean. We're going to do gasoline car, and we're going to figure that out. We're going to have to figure out the highway. We're going to have to figure out the city, right? I'm not figuring it out yet. I'm just putting my plan together. And then I'm going to have to do the electric, right? And I also am going to have to find the highway and the city. And then we're going to total these together, the highway and city, gallons of gas in the highway and city, gallons of gas on the electric car, and then we can make a determination on, how much gas you're going to use anyway. All right? So, coming back here, we see, we got to figure out the total highway and total city miles, and I'm going to do that up here, right? It said we've got 12,000 miles used, and a quarter, 25%, are driven on the highway. So we can do it like this. Oh, sorry, I now have the hiccups. And that gives us 3,000 miles when you do that. So 3,000, and don't just leave it like that. Write it down. 3,000 highway miles. And that means that we have 9,000 city miles. I mean, be explicit. Don't trust your brain to remember that, especially when you're doing a whole bunch of word problems. Okay? All right, so let's get back here and let's just do the math here. So here we're going to say this is how I set it up. For highway is 3,000 miles. Over 1, because it's not 3,000 miles per anything. That's 3,000 miles times that 1. And then we're going to multiply that with, what do we know here? We know we're highway miles. That's 35 miles per gallon on the highway. So that means we need miles to be on the bottom. So that means 1 gallon over 35 miles. That's how we have to set that guy up, right? We need miles to be on the bottom. We need gallons to be on top. And then we need to look here and see that it is 1 gallon to 35 miles. And then when we finish this math up here, we get 85.7 gallons. It's starting to storm now. I need to hurry up and get this done. All right, now we'll do the other piece here. This is going to be 9,000 miles over 1, and this time we're going to also put the miles on the bottom, but here we're working with city. The city, and the miles need to be on the bottom, so it's going to be 1 gallon to 24 miles. So we're right, miles down here, gallon here. So we have 1, we have 24. Make sure that the miles cancel. We're left with what we're looking for. That is going to be 375 gallons. And let's get that total. That would be for 460.7 total gallons. Right, and then let's do this other piece for the highway. Hold on, let me help myself out and make a little bit more room here. Highway and city. Okay, for the highway, we're going to start out again with the 3,000 miles over 1. We're going to do the exact same thing, but we're going to be using the thing for the hybrid cars. And that is for the highway, it was 40 miles per gallon on the highway. So we're going to have to put miles on the bottom, gallons on the top. So that's 1 gallon is 40 miles. Let's make sure everything crosses out correctly. Left with gallons. So that's going to be 75 gallons. And then we'll do this here, 9,000 miles over 1. We'll use the other 35 miles per gallon in the city. So we are going to have miles here, gallon here, 135. Let's see what our number turns out to be. 257.1 gallons. Adding those together, we have 332.14 total gallons. So for our comparison, really quick, and of course this was, I'm never perfect with these word problems I make up, but what we can say here is that the hybrid uses less gas. And of course that's dumb, and I can't think of what I want to say, and this is basically all I can do. I'm just so damn happy that I got this last video finally done that I just have to be peace out. You guys know when you're on the last second of a task and you just really can't focus on it? That's me right now. Thank you very much. Do not forget that your phrase, which I will not be reminding you of more than the next couple of lectures, is "A skunk borrowed my skateboard." Have a good day.